Hello, welcome back to Data Management with Stata. Module 2 is writing code. It's all about do files, and here's our agenda. We're going to go over command syntax. What do commands in Stata look like? We'll talk about what are do files and why do we care about them. We'll demonstrate how to create, save, and actually execute or do the do files. We'll go over some debugging techniques, talk about the different types of data that Stata can handle, and then take a look at your assignment for this week. My advice is to open up Stata and follow along at home. Syntax. Stata command lines are a language. Command names are verbs, and they describe an action, so they're very much like sentences. The subject is the computer, and it's implied, so you don't have to include a subject in any of your sentences. The object is usually one or more variables to be acted upon. So a basic Stata command will have a command, which is a verb, and an object, which is a variable. So it'll be a command like summarize is the verb, and the variable might be age. So the implied structure of the command or sentence is computer, summarize age. And that's a valid command, and the grammar works right. There are options that come after the comma, and they're kind of like adverbs. They modify the action. So it might be something like computer, summarize age, comma, detail, meaning do it in especially intense detail. There's some other syntax quirks that you can use in Stata, and they're kind of like abbreviations in the English language. Wildcards. You can use, particularly in file names, you can use a question mark for any single character. And that works out as summarize test question mark. We'll say, please give me summaries of test 1, test 2, test Q, test bar, test whatever, as long as there's just one character after test. If you use the wildcard star, then you'll get any string of any length. So summarize test star would give you all the ones you got above, plus test 1, 2, 3, testing, testosterone, whatever is in your data set like that. In Stata, case matters. Summarize is a good command. Summarize with a capital S is not a good command. And summarize lowercase age is not the same as summarize uppercase age. So what is a do file? A Stata do file is a text file that contains a sequence of valid Stata commands. It's also known as a script. It's a program that Stata can interpret and run, one command after another from top to bottom. It can have any file name, but it always uses the .do extension. The command run to do a file name is do, followed by the name of the file name. You don't have to add the do to the back of the file name in this case, but it doesn't hurt if you do. When you're building a do file, I advise using the built-in do file editor, and we'll show you how to do that in just 1 second. Now, why use do files? Well, the big advantage are reproducibility. You can go back a minute, an hour, a year later, and you run the commands on the same data sets, and you will get the same answers. And that means your research will be much more stable and reproducible. You can add comments and annotations to describe what you did and remind you why this variable is called that, or this command is structured this way. Why didn't you do X? Why did you do Y? That's something you can't do easily in other systems like Excel or other programs. And you can take longer, complex analyses and divide them into smaller chunks, get each one right, and then run them one after another. You don't necessarily have to get the entire thing right the first time through. The disadvantages are that it's a language and there's a learning curve and it's going to take practice. And as my mother used to say, it's easy when you know how. So, The first thing we're going to do is go to the Stata window, and let's go over to the menu on the top here and open the Do File Editor. And that'll be going to the menu, Window, scroll down to the Do File Editor, zip over to the right and hit New Do File Editor. And here's what you get now. So this is a blank document. You can put in any text characters you want, but of course those don't make any sense for Stata. So I'm going to replace that with a command that says display, when that's the command to tell Stata to put something in the results window, and just put this string. So let's start it with a quote mark. Hello world. And we'll hit return. And now let's just execute this file. So we're going to go over to menu on the top, tools, and let's hit execute, which is, you could also just do a keyboard shortcut of Control-D, and we executed it. Now I'm going to go back to the Stata window, and that we saw it. There's the command we typed in, and there's Stata's response, and then it says, okay, that's the end of the file. So this is a first little program, and it runs. We can go back to the Do window, the Do Editor window, and instead of going all the way up through all the menus, we can just do a Control-D. And then when we do Control-D, we see it did it again. Here's the first one, here's the second one. Let's go back once again, and let's save the file. So we're going to go to the menu, File, and Save. We could also do Control-S, or we could also just go to this button here, and then we could say, let's save this as hello.do, and it's now in our directory. Remember to make sure it's the right directory. That sometimes the operating system doesn't know where you are, and you might have to wander around the directory structure to put it in the right place. So let's go back to Stata, and let's do hello. And it didn't find it because I did not save it in the right place. So where are we now? Stata thinks our current working directory, pwd, is documents, but in fact that's not where I am. So I'm going to go up to File, Change Working Directory. I don't want to be there. I'm going to go to the place where I keep all of my Stata work for this class, and I'm going to go there. I'm going to type the dir command and look to see, and sure enough, there's hello. So now I can do do hello, and our command runs. Debugging is our next topic. There's two basic kinds of errors you're going to get after you've written a script. The first is Stata errors. Your code won't run, and those will usually show up with some sort of message. For instance, it might be a message like in red, file not found with a little secret code number. The other kind of programming error is when you get output and you get a result, but it's wrong. And that means something, perhaps a calculation or a logical error in your programming code. And Stata doesn't warn you about that. It can't know about them. And you need to look at your results carefully and see if they make sense. Sometimes running simple cases through your code first to make sure that they give you an answer that you know is true before giving it a difficult unknown set of data. One of the nice tools to help with debugging is when you add a comment. So you can add a comment by using a star character at the beginning of the line. And so anything after the star, the whole line is a comment. So we can go back to our script and perhaps at the beginning of the script, put in a star, or 2 or 3 if you like, that says this is a program to test out do files. And now when we do a Control D, or do the file, we can see the comment in there and the commands, and it didn't do anything different, it just printed out the command. The next kind of comment we can do is at the end of a command. We can do it this way. We can put 2 slash marks and put a comment on there. And the reason, and this will run completely ignoring everything after the 2 slash marks. And that reminds me that we don't have to say display. We can shorten most static commands to the shortest string that makes them unique. So there's no other commands that start with a DI, so you don't have to type out all of display. And now when we run this entire one, what we see is this command line has this comment there that will help us remember what we did in that one. And then the final option is a comment can have a slash star with many, that's called a block comment. Everything from here on in is not executed, and it's just treated as a comment all the way until you hit the reverse comment. So slash star to start it, and star slash to end it. And that means we can do things like, well, let's see. Here is a block of program that isn't correct. It has a bunch of coding errors. When we do this, I just hit the do command, and this first command isn't valid. It's not a recognized command. Here is not a Stata command. So, in fact, this whole chunk needs to be debugged. I didn't do it right. I'm going to block it out. But I'm going to add another command down here that says now when I execute it, this is another button that'll let you execute it up here. It gets all the way through to the end. This comment didn't cause any trouble. This comment didn't cause any trouble. The command executed. This block just was just displayed, but nothing was done with it. This command did operate, and that was the end of the do file. Finally, there are some commands that are really long, and they will do so long that they don't look good in one row. You can't see them on, they're so long they don't fit on the screen. And what you can do is put 3 slashes, and the command just wraps around and keeps going on the next line. And that's handy for occasional commands. By the way, anything after the slashes is a comment. And it'll just keep going until you come to a line that just has a regular character. The next thing I want to talk about is data types. Inside the computer, everything is just a collection of binary digits, zeros and ones. But Stata can store all sorts of stuff as binary codes. The most obvious one is numbers. Numeric data can be integers, numbers, whole numbers, including negative whole numbers, 0 plus 1 minus 78,000 and so forth. Small numbers it'll store as a byte, and those are usually just 0, 1, or if it's a value that'll go up to 15 or so. But if it's bigger than that, it's going to use more storage space, and then it'll be an integer storage space. If you have real numbers, that means floating point numbers or double floating points. These are numbers where you want to be able to take care of decimal fractions or ratios. 1 over 3 is 0.333, etc. And that's a real number that Stata can store, but it's going to take more storage space. The thing to know about numeric data is that arithmetic works on it. If you take an integer 7 and another integer 5 and add them together, you will get an integer 12. It makes sense. You can do subtraction, multiplication, division, and so forth. Categorical or nominal data are also stored as bytes or integers. And this is a situation where each value is a number, but it also has a text label. And really the text contains the information. So this will be things like blood groups or employment categories, or the kinds of data where we just want to name a characteristic and there's no implied numeric value. Now, Stata is storing it as a number with a pointer to the name or the label that denominates it. And so since it's a number, you can do arithmetic, but it kind of doesn't make any sense. Finally, there's alphanumeric or string data, and this is letters, symbols, and digits, like that string hello world. And you can't do any arithmetic on it, but it's exceedingly useful data. And then a big category of data that we care about are dates and times. Dates in particular. Now, Stata stores dates as numbers before or after a 0 time, and if it's after the 0 time, it's a plus value, it's a positive value, and if it's before that 0 time, it's a negative value. For dates, the 0 time or epoch started on January 1st, 1960. Someone born on January 1st, 1960 has a birth date of 0. And someone born on January 1st, 2000 has a birth date of 14,610, which is how many days have elapsed since the beginning of 1960. You can be born before 1960, and my birthday is minus 671 in Stata readable format. You don't have to do it in days. Stata can keep track of milliseconds, weeks, months, quarters, half years, and years, although days are the most common. Now, if you do type out a date and just ask for it, Stata says, well, that's a number, and shows you a number, and something happened on March 28th of 2019. You ask Stata to show you the date, and it gives you a 21636. But that's not very user-friendly. But if you put a command in front of it, or a little an option in front of it, a format code, %TD. Now, all format codes start with a %, and this one means take that number and show it as a date. So if you display %TD 21636, what you get is 28 March 2019. And if you display TD -3, well, that's 3 days before New Year's 1960, or 29 December 1959. Dates do allow arithmetic. So if you want to know something about what happened a year before this event of 21636, you can do display TD 21636 minus 365, and you get a very sensible response there of 28 March 2018. The last thing to talk about in data for now is sometimes we don't have a value for a variable. We've got a bunch of subjects, and most of them we know their age, and that's, say, an integer value in the nearest year. But some of them, their age was never recorded. So, or we have their middle initial for most people, but their middle initial was not recorded for some people. So if it's a string value, like initials or names, we just use a null string, quote, quote. If it's a missing number, Stata presents it as a dot, a single dot. And now, dot is actually a number. And Stata sets dot to be the biggest number it can store, because you're almost never going to want to do math up at that, value of a gazillion up there. So it's a pretty safe place. However, it's actually a number, and in certain circumstances, Stata will do math on it. So we've covered a lot of material today. We've covered commands, and we've covered making Stata files in the editor, and saving them and running them, a little bit about comments, a little bit about missing data and data types. Your assignment is to import a data set called VDIS_small.xls, describe the data set, list the first 10 records, codebook the two variables BMI and BMI cat, summarize two variables called age and ETOH, tabulate the variable called BMI cat, summarize the A1C values for each BMI category, and then some graphics. Make a histogram of A1C and a box plot of A1C for each BMI category. So this is a script. Please save it as a do file. Add comments and annotations to make it easy to read, and bring it with you to class. Thank you.